Hello class, it's just me, Mr. Wee. So I'm going to be here to help you out with section 1-6 for solving x squared plus bx plus c. So if you don't know what that means, let me first give you a problem that you should see in guided practice number 1 in this section. So I'm going to kind of lay out what this section is sort of telling you and how to solve for this. So the first thing you're going to see is that they're going to give you this problem, x squared plus 9x plus 20. And before, I believe what you were used to seeing was you're used to seeing binomials, right? X plus 3 times x minus 2, let's say. And you're used to actually factoring, or I'm not factoring it out, but multiplying it out to where you'd get a result, right? You get x squared plus, or I'd say, plus x minus 6, right? So you get some kind of result like this. In this section, it's asking you, what if we were given this and we had to go backwards, back to this? So could you take this problem from guided practice number 1 and then work backwards to see what the two binomials were? So we have a 3-term polynomial or trinomial. Could you go backwards and factor it? So I believe it will ask you to factor out this polynomial back into its smaller binomials being multiplied together. That looks really hard, but it's not too bad. Okay, so let me show you some techniques. I know that the book has some certain techniques, but I think I'm going to go over a method that's a little bit easier. So the first thing that we have to do, though, is to identify what they didn't mention is an A, B, and C. What your A, B, and C are in this. So what do I mean by that is, if you look at the general formula, this is the general formula for any polynomial or any 3-term polynomial, trinomial, and it has to be a second degree, meaning it has to be to the second power, at the highest the second power. This really only works if you have a second power. This technique I'm about to show you only works if you have a second degree polynomial, meaning it can max out at exponent of 2 next to the variable. Ax squared plus bx plus c. If you think about it, that's the general way of writing it. If you look at any other specific problem, you can identify and kind of see from the general formula what your c is. Your c would be a constant. It's not next to an x. I presume that's 20. So in this case, our c's are 20. You don't have to write this down, but or actually this would be good notes. I would actually suggest writing this down. Your b would be whatever's in front of just x to the first power. In this case, it'd be 9. And then what would your a be? Well, your a would be whatever's in front of x squared, but if there's nothing technically in front of x squared, it is 1. Now, please think to yourself why a couldn't be 0 if a is not visible. Well, if a was 0, right, and you put 0 in the front of x squared, you're implying that that's 0 times x squared, which would mean that this would just be 0 if you think about it. So if I had 0 in the front of here, it'd be 0 times x squared, which wouldn't make any sense, or else we wouldn't even see x squared. But because we see x squared, we can presume that your a is actually 1. Okay, so this trick, so make a note, we're going to go through a technique. You're going to learn other techniques, but this is a technique, the easiest technique that only works when a is equal to 1. Okay, this is a technique that only works when a is equal to 1. So this is fairly simple. What you're going to do is, you can look at it here. You're going to look at it like this. Here, what you're going to do is you're going to set up x plus. You're going to leave it like that. You're going to figure out two numbers. So we already know that it's going to be two binomials that have an x in there. Okay. The reason why is because I know that the way it multiplies out, you're always going to multiply the x and the x once, like that's going to give you x squared, and the rest just kind of work itself out to get you the rest of the terms. Well, I know I need to get to x squared plus 9x plus 20, so I know the very first things that should appear are the x and the x. That's not a big deal. I'm trying to figure out these other two numbers. Okay, so what I recommend is this only works when your a is equal to 1. Okay, meaning that front number is 1. Okay, that only works. So we're going to learn of other techniques when a is not equal to 1, but here we go. So we got to think of a number that I believe multiplies to c. so whatever your C is, but adds up to B. Two numbers that multiply to C and add up to your B. So I call this a diamond problem. A diamond problem, because it sort of resembles a diamond. I'm not really sure if that's true, but you can kind of see it doesn't look like a diamond. But your C in this case in your original problem was 20. And then your B was 9. So let's think of two numbers that could multiply up to 20 but add up to 9. So I'm thinking of maybe 20 and times 1. So that doesn't really work. So if I did 20 times 1, that doesn't really work because 20 times 1 is equal to 20, but it doesn't add up to 9. So that's probably not my solution here. Whoop. Okay, so that's probably not going to work. Let's go down the line. How about 10 and 2? 10 times 2. 10 times 2. That multiplies out to 20, but does not add up to 9. 10 plus 2 is 12. That does not add up to 9, so that doesn't work. The next thing that I can think of would probably be 5 times 4. There we go. 5 times 4 is equal to 20 and adds up to 9. That's perfect. So what we do with these two numbers is that we just put them in the polynomial here, or I'm sorry, the two binomials here and here, and that's good. That should be our answer, but in case you don't know if that's your actual answer, you could check your answer. So just letting you know here, these are just notes. This is the problem. This is what you need to write to get it down to get your answer. So on your homework, I should see this. I should see the work, or this is the final answer, and here's the work here. Okay, this is what the work could look like. All right. So I'm going to give you another problem after this, but let's just double check. So this is a way to check your answer. So this is checking your answer. Checking your answer will look like this. X plus 5 times x plus 4. You simply do what we've been doing this whole time. We distribute the x to both of these numbers, and you multiply the 5 to x and 4. So what you're doing now is, remember how I told you we were once going from multiplying two binomials to getting a polynomial? Well, if we factor out the polynomial back into the binomials, and that's what I did, I got two binomials, we could check to see if this is whatever we got was correct by going back this way and seeing if we get the same polynomial we started with. Okay, so I think that's a lot of talking, it's really confusing, but let's just see what that looks like. X times x is x squared, x times 4 is plus 4x, 5 times x is 5x, and then 5 times 4 is 20. We just add everything together really quick. And is this the same as what we originally asked and started with? Yes, it is. So that means this answer is a correct answer. Okay? So let me give you a sample problem really quick. Let me give you a sample problem really quick that you can try on your own. So this is x squared minus 8x minus 12. You can pause the video just to give that a try, or you can just watch me kind of come up with the solution right here. So here, let's factor this out into two binomials. Factor into two binomials. This is a problem, binomials. You can try this out, pause me right now if you want. So you need to come up, so again, what's your A? My A is going to be 1. My B is going to be, technically it has that negative in front, so that's negative 8. And the C is, I'm going to say it's negative 12. Okay, I'm going to include that minus sign that's right in front of it. So you need two numbers that multiply up to negative 12, the C, and then to add up to negative 8. So I got, so let's try negative 12 and 1. So that would give me negative 12 times 1. That would give me negative 12, but they add up, that adds up to negative 11, so that can't be it. How about negative 6 and 2? Negative 6 times 2. That looks good, but negative 6 times 2 is negative 12, but it adds up to negative 4, so that's actually not the correct answer. Oh, I'm sorry. You know what, guys? Ugh. Mr. Wee made a mistake. I'm so super sorry. This might change everything. That's supposed to be a plus 12, guys, and the C is going to be a positive 12. You dope, Mr. Wee. Okay, sorry about that, guys. Okay. So let's start over. I'm so super sorry. So I'm sorry if you were trying this whole time on your own, you couldn't get the answer. So let's just start over again. I'm sorry, guys. Okay, so two numbers to start or that multiply up to 12 but give me -8. Well, 12 times 1 doesn't really work because that would add up to 13. In fact, 6 times 2 wouldn't work because that would add up to 8, not -8. So 6 and 2 don't work, but I'm getting close to something. How about 4 and 3? Why not 4 and 3? 4 times 3 is 12, but again, adds up to a +7. So you know what, guys? I'm thinking that I could actually multiply negative numbers together, like -12 and -1. Okay, so -12 times -1 do technically multiply up to +12, but they do not add up to -8. It adds up to -13. How about -6 and times -2? Let's try that. -6 times -2. Ooh, -6 times -2 is +12, and you add them together, you get -8. This works. So this is the question. Your answer should have been x. What you're gonna do is you're gonna have x plus and x plus, and in these positions in the blanks, they should be -6 and -2. And if you think about it, I'm going to put parentheses around them so you can see that there's a plus sign in front of here, and this is a -6, and this is a -2 being added to x. You can simplify this to make it look like if you're adding a negative number, it's the same thing as just subtracting it. Again, if you're adding a negative number, it's the same thing as subtracting it. So this is what your final answer should look like. So this is the answer. You can check your answer then by going the other way, by just multiplying this out really quick. So if you just want a quick check, so this is my quick check really quick. I'm going to multiply this out the other way. So I'm going to go, so I went this way, and I'm going to kind of multiply this out and see if I can get the same answer that we started with. So this should be x times x and x times -2. So that'd be x squared minus 2x. And then over here should be -6 times x and -6 times -2. So -6 times x is -6. X and -6 is being multiplied to -2, which gives me +12. There we go. That is a good check. Sorry. To see if my answer was correct. This is exactly the same thing that we started with, meaning that this is a good answer. So really, this is your final answer. But on the exam, if you have time, maybe then check your answer really quick. Okay. All right, guys. I'm going to stop right here, but I'm going to graph and show you how to use the TI-83 on the next video. Okay. You guys have a great day. Bye.